Okay, integer exponents, concept 1.5, exponents with base 10. So in the last video, I don't think I did a good enough job explaining how to work with base 10 numbers with exponents, whether they be positive or negative. The table makes it look pretty straightforward, and it is pretty straightforward, but there's a lot of different things that you will use base 10 with exponent numbers to do. So we want to make sure that we really got it. Okay. The rules for figuring out the number when you have a base 10 with an exponent is if it's positive, it's just going to have that many zeros. Okay, however large the exponent is how many zeros it's going to have. So if I have 10 to the second, I'm going to have 2 zeros. Right? If I have 10 to the 10th, I'm going to have 10 zeros. 4, 5, 6, 7, 8, 9, 10. And you can see that with base 10, we have a way to quickly express really large numbers, right? I could have 10 to the 50th, and that would take me quite a long time to write all those zeros out, but it's very easy to just write 10 to the 50th, okay? Now, when you have negative exponents, it's a little trickier, but it's very similar. Okay, so negative exponents, so we have 10 to the third up here. If we have 10 to the negative third, I'm going to basically reverse this number. So 0, 0, 0, 1. And then my decimal point goes right there. Okay. The reason I don't have my decimal point out here is because when you have, say this is a 0, and then we just have our values, our place values. Okay, this is our ones, tens, hundreds. This is our tenths, hundredths, thousandths. Right, so we don't have a once digit on the right of our decimal place. Okay, it just starts with the tenths. That's why we need to basically move our decimal place 1 over. Okay, so if I look at a larger number, 10 to the negative 7th, 1, 2, 3, 4, 5, 6, 7, drop my 0, and then my decimal right there. Okay, good. Now, how we use these numbers is to change the decimal place in a large number, right? So if we have pi, here's pi out to 10 digits, all right? And if we want this to be a larger number, we could write this as, or we could multiply this by 10 to the, let's go 9th, okay? Times 10 to the 9th. Okay, so that's basically going to have the same effect as multiplying it by 1, 2, 3, 4, 5, 6, 7, 8, 9, right? These two numbers are equivalent. But what's going to happen to this when I multiply it by this many zeros or by this large of a number? Well, it's going to move over one place for each zero, right? I have 9 zeros, so this is going to move over 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my answer would be 3, 1, 4, 1, 5, 9, 2, 6, 5, 3. And my decimal would be right there at the end. Okay. You can do the same thing with a negative exponent. So if I go back to my 3.1, 4, 1, 5, 9, 2, 6, with my decimal place over there, and I multiply it by 10 to the negative fifth, okay, that's going to have the opposite effect. I'm going to go to the left. Right? So I'm going to go 1, 2, 3, 4, 5. There's my new decimal place. I'd have 0, 2, 3, 4 more zeros. And then if I want, I can throw my 0 on the left of my decimal place. Okay? So multiplying by 10 to an exponent has the effect of shifting a decimal place within another number. And we're going to be using this quite a lot later on in these lessons, or in this chapter.